We'll talk quite a bit about parameters and arguments, so let's revisit those definitions before proceeding. In common usage, the terms parameter and argument are often interchanged. However, for the purposes of further discussion, we will make a distinction between the two. A function parameter, sometimes called a formal parameter, is a variable declared in the function declaration. Void foo, int x, declaration, function prototype, x is a parameter. Void foo, int x, definition, also a declaration, x is a parameter. An argument, sometimes called an actual parameter, is the value that is passed to the function by the caller. Foo, 6 is the argument passed to parameter x. Foo, y plus 1, the value of y plus 1 is the argument passed to parameter x. When a function is called, all of the parameters of the function are created as variables, and the value of the arguments are copied into the parameters. There is one more way to pass variables to functions, and that is by address. Passing an argument by address involves passing the address of the argument variable rather than the argument variable itself. Because the argument is an address, the function parameter must be a pointer. The function can then dereference the pointer to access or change the value being pointed to. As you can see, the function foo changed the value of the argument, variable value, through pointer parameter ptr. When you pass a pointer to a function by address, the pointer's value, the address it points to, is copied from the argument to the function's parameter. In other words, it's passed by value. If you change the function parameter's value, you are only changing a copy. Consequently, the original pointer argument will not be changed. Example. The next logical question is, what if we want to change the address an argument points to from within the function? Turns out, this is surprisingly easy. You can simply pass the address by reference. The syntax for doing a reference to a pointer is a little strange, and easy to get backwards. However, if you do get it backwards, the compiler will give you an error. Example. Int foo1, int x, pass by value. Int foo2, int end x, pass by reference. Int foo3, int asterisk x, pass by address. Int I. Foo1, I, can't modify I. Foo2, I, can modify I. Foo3, and I, can modify I. Advantages of passing by address. Pass by address allows a function to change the value of the argument, which is sometimes useful. Otherwise, const can be used to guarantee the function won't change the argument. However, if you want to do this with a non-pointer, you should use pass by reference instead. Because a copy of the argument is not made, it is fast, even when used with large structs or classes. We can return multiple values from a function via out parameters. Disadvantages of passing by address. Because literals and expressions do not have addresses, pointer arguments must be normal variables. All values must be checked to see whether they are null. Trying to dereference a null value will result in a crash. It is easy to forget to do this. Because dereferencing a pointer is slower than accessing a value directly, accessing arguments passed by address is slower than accessing arguments passed by value. While pass by value is suitable in many cases, it has a couple of limitations. First, when passing a large struct or class to a function, pass by value will make a copy of the argument into the function parameter. In many cases, this is a needless performance hit, as the original argument would have sufficed. Second, when passing arguments by value, the only way to return a value back to the caller is via the function's return value. While this is often suitable, there are cases where it would be more clear and efficient to have the function modify the argument passed in. Pass by reference solves both of these issues. To pass a variable by reference, we simply declare the function parameters as references rather than as normal variables. Void add1, int end ref, ref is a reference variable. Ref equals ref plus 1. When the function is called, ref will become a reference to the argument. Since a reference to a variable is treated exactly the same as the variable itself, any changes made to the reference are passed through to the argument. This program is the same as the one we used for the pass by value example, except foo's parameter is now a reference instead of a normal variable. When we call add1, value, ref becomes a reference to main's value variable. Sometimes we need a function to return multiple values. However, functions can only have one return value. One way to return multiple values is using reference parameters. This function takes one parameter, by value, as input, and returns two parameters, by reference, as output. Parameters that are only used for returning values back to the caller are called out parameters. We've named these out parameters with the suffix out to denote that they're out parameters. This helps remind the caller that the initial value passed to these parameters doesn't matter, and that we should expect them to be rewritten. Let's explore how this works in more detail. First, the main function creates local variables sin and cos. Those are passed into function getSinCos, by reference, rather than by value. This means function getSinCos has access to the actual sin and cos variables, not just copies. GetSinCos accordingly assigns new values to sin and cos, through references sin out and cos out respectively, which overwrites the old values in sin and cos. Main then prints these updated values. If sin and cos had been passed by value instead of reference, getSinCos would have changed copies of sin and cos, leading to any changes being discarded at the end of the function. But because sin and cos were passed by reference, any changes made to sin or cos, through the references, are persisted beyond the function. We can therefore use this mechanism to return values back to the caller.